Okay, so the first two problems we're given the length of three sides, and we're asked to find the angles, all the angles. And you can use the law of sine. Once you get one angle, you can use the law of sines to get the other angle. And then you could use the sum of the angles equals 160 to find the third angle. So we don't have to use the law of cosines three times. Now the law of cosines says that c squared is equal to a squared plus b squared minus 2ab times the cosine of the included angle c. So in our case, we can choose any angle to start with. So that's, you could have a squared is equal to c squared. A squared, let me just write these out. So there's three versions depending upon which angle you're trying to find. So you get a squared is equal to b squared plus c squared minus 2bc cosine of a, and then b squared is equal to a squared plus c squared minus 2ac cosine of angle b. So again, it doesn't matter in this case which ones we want to solve for first. So let's just do A. Start with A. So you can see that I can, if I want to solve for the cosine of A, instead of plugging the numbers in, then solve. Well, I guess there's two ways. You probably would feel better me just plugging in the numbers and then. So let's just do it. So A is 7. So I'm using this equation. 7, B is 10, C is 15, minus 2 times 10 times 15 times the cosine of angle B, of angle A. So let's do that. 49 is equal to 100 minus 15 squared is that 225? I think so, yeah. 225. So plus 225 minus 2 times 10 times, that's 300. 150 times 2, 300 cosine of A. So if we get negative 300 cosine of A, and if you take 49 and subtract 100, subtract 225, you'll get negative 276. So the cosine of A is negative 276 divided by negative 300, which is less than 1, so that's good. Negatives cancel out. We end up with 0.92. So A is going to be the inverse cosine of 0.92. So the inverse cosine of 0.92 is 23.1 degrees. Now, again, just reality check. Here, A is the smallest length, so it should have a fairly small angle. So that agrees with that instance. Now, we could then find side B using the law of, angle B, using the law of cosines. We'll do it both using the law of sines and the law of cosines. Sure you get the right answer just this one time. So if we use this equation, and I've already forgotten what the numbers are here. So let's write these down. What I'll do is insert a page here. B equals 10, A equals 7, C equals 15. So we'll use this one. So we get 10 squared is equal to 7 squared plus 15 squared minus 2 times A times C times the cosine of angle B. So we'll take 100 minus 49 minus 225. So you get 100 minus 49 minus 225. So I get negative 174. And if we take 2 times 7 times 15, we get negative 210 cosine of b. So we get the cosine of b is 174 divided by 210, which is 0.828. So b is the inverse cosine of 0.828. So that's 34.1 degrees. Okay, so that's using the law of cosines. Now, from the first step, we got an angle of 23.1 degrees. So the other way to solve this problem is to use the law of sines, and that says the sine of A over A is equal to the sine of B over B. So the sine of B, if I solve for the sine of B, because I'm trying to find B, sine of B is equal to the sine of A times B divided by A. So we have the sine of A, which is 20, got that from the previous step, 23.1 degrees, times B, which is 10. Going over here and look at these numbers, 10, and A is 7. So the sine of 23.1 degrees times 10 divided by 7 is 0.560. And then B is the inverse sine of 0.560, and it should end up being 34.1 degrees. So the inverse sine of 0.560 is 34.1 degrees. So we do get the same answer. Now, you're always going to have to, when you're given three sides, you're always going to have to use the law of cosines to find one angle. Now, finally, side C, or angle C, is just 180 minus the other two angles, 34.1 and 23.1. So we get 180 minus 34.1 minus 23.1, which is 122.8 degrees. And if we go back and look at our thing, you can see that C is the biggest angle, and it looks greater than 90 degrees. A is the smallest angle, which is, we calculated to be 23.1, and this one is the 34.1. So the scaling looks pretty good as far as the drawing is concerned. Now here we have another one. Is the order different? So you can see the relative size are fairly comparable to this, so it's going to look similar to this triangle. Now, when you have, are there multiple solutions to these, and how do you know if there are multiple solutions? That's a good question. So, yeah, I think there's only one solution. Yeah, if you have three sides given, there's only one solution, so you don't have to worry about getting multiple solutions. So again, we'll go through the same process here. So let's solve for angle A. Don't really need to, we can choose any one of them. So solve for A. So we're going to have A squared is equal to B squared plus C squared minus 2BC cosine of A. So this left-hand side has to match up letter-wise with the argument of the cosine. And I just was looking at my book, and you can use, this is the standard form, or you can use the alternate form, which says the cosine of A is equal to B squared minus B squared plus C squared minus A squared over 2BC. And that's just solving this algebraically for the cosine of A. So instead of, let's just use the alternate form. So B is 14, C is 20, A is 11, B is 14, C is 20. Plug that in the calculator, so you get 14 squared plus 20 squared minus 11 squared. So the numerator is 475, and the denominator is 2 times 14 times 20, which is 560. So 475 divided by 560 is 0.848. So the A is the inverse cosine. And the answer is 31.98. I'll say it's 32.0 degrees. Okay. So again, we could use either the law of sines or the law of cosines. I'm just going to use the law of cosines again. And I'm going to use the alternate form. So you get the cosine of B is A squared plus C squared minus B squared over 2AC. Cosine of B, so A is 11, C is 20, B is 14, A is 11, C is 20, cosine of B, so you get 11 squared plus 20 squared minus 14 squared. 325, and 2 times 11 times 20 is 440. 325 divided by 440 is 0.739. So B is the inverse cosine of 0.739. And I get 42.3 degrees. So C is 180 minus 42.3 minus 30. Which one are we at here? And A was 32. So let's minus 32. 180 minus 42.3 minus 32 is 105.7. Now, let's do it where the angle is 105.7 and see if it just falls out. So rather than using this equation, I could use the final example of the alternative form of the law of cosines. So A is 11, B is 14, C is 20, divided by 2 times 11 times 14. So 11 squared plus 14 squared minus 20 squared is negative 83. And that's critical because that's going to, when we take the inverse cosine, because the inverse cosine has a range between 0 and 180 degrees, or 0 and pi, this is going to work out perfectly. And the denominator is 308. So the cosine of C is negative. So I get negative 0.2695. So C is the inverse cosine of negative 0.2695. Plug that in your calculator, and I get 105.6 degrees. So you can see I get the same answer by using the alternative form of the law of cosines and by just subtracting the other two angles from 180. And I could also have found angle B using the law of sines. Basically the first angle, there's only one way. That's to use the law of cosines. The second angle, you can use the law of cosines or the law of sines. And then to find the third angle, you could use the law of sines, the law of cosines, or the sum of the angles equals 180. Okay, so that's the first two problems. Now, the next group, you see the next one is pretty much the same as we've given three sides again. This one, because the two sides here are equal to each other, we're going to have an isosceles triangle. So we should have two angles being the same. So if we find angle B, we should be able to say that's equal to angle C if we wanted to. Number 4, we're given two sides and an angle, but you can still use the law of, well, the difference here, notice, is that the angle is different than these two. So if we were given this length of side, or the angle A or angle C, we could use the law of sines, but because this angle is not the one that's associated with these sides, then you have to use the law of cosines. The same way here, we're given angle B, we're given sides A and C. Here we're given C angle, we're given sides A and B. So all of these require the law of cosines. So number 3, just so we have practice at using the law of cosines, we'll just use the alternative form. So the cosine of A is B squared plus C squared minus A squared over 2BC. So what do we have? B is 52 squared plus C, which is 52, minus A squared. So that's 75.4 squared divided by 2 times 52 times 52. That's the cosine of A. So let's see, we get 52 squared plus 52 squared minus 75.4 squared. And it's negative 277.16 divided by 2 divided by 52 divided by 52. And I get negative 0.05125. So A is the inverse cosine of negative 0.05125. It's going to be very close to 90 degrees. Inverse cosine of the answer, 92.94. So that's angle A. Now, because this is an isosceles triangle, we know that these two angles have to be the same. So we're going to do it that way, but we'll work it out. So if you had 180 minus 92.94, that gives you some number, 180 minus 92.94, which is 87.06. And if you divide that by 2, angles B and C are going to be the same. So you divide that by 2. So it's 43.53 degrees. Okay, so that's using the fact that I saw these are equal to each other. Now, if you didn't gather that, we could calculate angle B. The cosine of B is going to be A squared plus C squared minus b squared all over 2ac. So the cosine of b, so a is 75.4, square that, plus c, which is 52 squared, minus b, which is 52 squared. So you can see those cancel out. Divided by 2 times 75.4 times 52. So the cosine of b is 75.4 squared. That's the numerator. Divided by 2, divided by 75.4, divided by 52. So you get 0.725. B is equal to the inverse cosine of 0.725. And I get 43.5 degrees, which is the same answer I got right there. So you could find c, the cosine of c would be a squared plus b squared minus c squared over 2ab. Or you could, now that I know this angle and know this angle, I could add these two together, subtract from 180, and I'd end up getting c is equal to 43.5 degrees. Okay, now the next one, what we want to do is we want to find side A, because if we write this form of law of cosines, we get a squared is equal to b squared plus c squared minus 2bc times the cosine of a. So we know everything on the right hand side. So let's plug that in there. So you get 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 55 degrees. So a squared, and then we'll take the square root. So we get 9 plus 100 minus 2 times 3 times 10 times the cosine of 55. So that is 74.58. Take the square root. You get 8.64. So that's A, 8.64. And then to find B, angles B and C, we can use the law of cosines or the law of sines. Let's just use the law of sines. We haven't used that for a while. So that would be the sine of A over A is equal to the sine of B over B. And I should use a lowercase here because those are the lengths for the sides. So it's sine of A over small lowercase. So in our case, let's just plug the numbers in. Sine of 55 degrees divided by 8.64 is equal to the sine of B, which I don't know, divided by B. So if you solve for the sine of B, it's going to be equal to 3 times the sine of 55 degrees divided by 8.64. So sine of 55 times 3 divided by 8.64 is 0.2844. And if we do the inverse sine, I'm not going to write it down. Done enough of these. Inverse sine of 0.2844 is 16.5 degrees. And then you could find angle C. So here's angle B, 16.5 degrees. So C is going to be equal to 180 minus 16.5 minus 55. So I get 108.5 degrees. And again, what we should see is that as these angles get smaller, the length should get smaller. So the highest angle has the highest length. The next angle has the next highest length, and the smallest angle has the smallest length. And again, you could have used the law of sines and cosines. You could use the law of sines to find C if you wanted to. You'd still get 108.5. So I'm going to pause just to make sure I did that one right. Okay, so that is right. Next one, same kind of deal. So we're going to use the law of cosines, and we're going to find side B. So b squared is equal to a squared plus c squared minus 2ac times the cosine of angle B. So we get b squared is equal to a squared, which is 6.2 squared, plus c squared, which is 9.5 squared, minus 2 times 6.2 times 9.5, and then that so they got mixed up a little bit when I .75 degrees 20 minutes. Okay, so that one's a little, we got to convert. So our calculator won't take minutes. So what we have is 75 plus 220 divided by 60. So the 60 seconds per 60 minutes per hour. So that's going to be 75.33. 20 divided by 60 is a third, which is 0.33. So we're going to evaluate, we'll use 75.33 there. So 6.2 squared plus 9.5 squared, 9.5 squared minus 2 times 9.5 times 6.2 times cosine of 75.33, and we end up with that b squared is equal to 111.3, or taking the square root of that, we get b is equal to 10.55. So let's go ahead and write that down. So b is equal to 10.55. Okay. The next one, we can use the law of sines. Let's use the law of cosines again. So in this case, we'd use the alternate form, which says the cosine of A is equal to b squared plus c squared minus a squared over 2bc. I think that's right. Let me double check the formula here. Cosine of A is b squared c squared minus a squared over b. Okay. So now we can just plug the numbers in. I've got them all here. 9.5. So b is 10.55 squared plus c, which is 9.5 squared, minus a, which is 10. Oh, got something wrong here. Oh, a is 6.2. 6.2 squared, all divided by 2 times b, which is 10.55, times c, which is 9.5. So that's the cosine of A. So the cosine of A, so plug this in our calculator, 10.55, 5 squared plus 9.5 squared minus 6.2 squared divided by 2 divided by 10.55 divided by 9.5, and I get 0.814. So A is the inverse cosine of that number, which is 35.5 degrees. So that's A, so I'll write that down. Angle A is 35.5. And then angle C, all we have to do there is C is 180 minus 75.33 minus 35.5. 180 minus 75.33 minus 35.5 is 69.2 degrees. 69.2. So again, let's look at the magnitude of these things. So the smallest angle should have the smallest length, which is true. The next one should have the next higher length, which is true. And the largest angle should have the longest length. And notice that these are reasonably close to each other because the two angles are reasonably close to each other. So I believe that's correct. But since I have this, I can look it up. So let me just do that. Okay, so when you calculate this, you get 97.9. And you take the square root and you get 9.89. So that's B, and the reason this number over here is wrong, different, is because originally I did it wrong. So rather than, I'm re-recording it so you miss out on having to fix your papers. So let's go ahead and erase those. Okay, so with B known, you can use the law of cosines or the law of sines again. So what I'm going to do is fix these numbers. So this should be 9.89, and this should be 9.89. If we redo the calculation, 9.89 squared plus 9.5 squared minus 6.2 squared divided by 2 divided by 9.89 divided by 9.5, we get 0.796. And if you take the inverse cosine of that, you get 37.2. And then if we subtract 37.2, so that was angle A here, 37.2 degrees, from that, and then you also subtract 75.33, 180, and just looking at these relative, these are pretty close to each other. So the angle should be slightly less than 75, because 75 gives you 9.89, so 9.5 should give you 70 something, I would think. And I get 67.5 degrees. Okay, so we're going to pause and make sure that is right now that I've worked through it. Okay, there's a slight error, but I'm not going to go back. If you got numbers slightly different than that, then you're probably correct, but they're not very much different. So this last problem here of this group, same kind of deal. So what we'll do is we'll say c squared is equal to a squared plus b squared minus 2ab cosine of angle C. So we get c squared is equal to a, which is 4/9 squared, plus b, which is 7/9 squared minus 2 times 4/9 times 7/9 times the cosine of 43 degrees. So let's plug that in. 4 divided by 9 is that, square it, plus 7 divided by 9 squared, minus 2 times 4 divided by 9 times 7 divided by 9 times the cosine of 43 degrees. So something's wrong because I got a negative, so let's go back and look at it. So 4/9 squared plus 7/9 squared. Oh, here, I see what here. 2 times, I gotta put a times in there. 2 times 4 divided by 9 times 7 divided by 9. Enter. So you get 2.20. So C is equal to the square root of that, which is 1.484. So that's length C is 1.484. Now I'm just looking at that and it's bothering me a little bit because this angle, 43 degrees, I shouldn't be getting that big a number because relative to A and B, there seems to be something wrong. So what I'm going to do here is just pause it a second and see if I can figure out what's going on. It doesn't seem correct. Because these, if I think about, even if these were equal, if these two angles were equal, they would be, let's see, 180 minus 43 would be 137. 137 divided by 2 would be about 130 something, about 70 something. And if I had an angle of 70, but this length is shorter, then something is obviously wrong. So let's pause it. Okay, I don't know what I did wrong, but that is not the right answer. So here you get 0.297, and you take the square root of that, and you get 0.545. So that's the length here, and that makes more sense. Okay, so then I can find angle A, and I could find angle B. So again, I'm going to use the law of sine. I'm going to use the law of sines in this case, just because I can. So it says the sine of C over C is equal to the sine of A over A. Again, just to be different here, I'm going to algebraically solve for the sine of the angle. So the sine of A is going to be equal to the sine of C times A divided by C. So I get the sine of C is, so I know what the sine of, I have the sine of 43 degrees is equal to 4/9 divided by 0.545. Okay, so let's figure out what the sine of angle A is. So we take the sine of 43 degrees times 4 divided by 9 and divided by 0.545. So the sine of A is 0.556. So A is the inverse sine of 0.556. So we get 33.8 degrees. So that's that, 33.8 degrees. And if you 4/9 is 0.444. So this is the smallest angle, should have the smallest length. This has the next smallest angle, that should have the next one. And then we can calculate angle B. It's going to be 180 minus 33.8 minus 43. So we get angle B is 103.2 degrees. So that's problem number 6. Okay, moving on. It says complete the table by solving the parallelogram shown in the figure. The lengths of the diagonals are given by C and D. So you can see the triangle here. This is C and this is D. And we're given 3 out of the 6 things that we need to do. So what you can think of is, for example, here we know A and we know B. So what can we do with that? And we also know theta is 45 degrees. So let's check first if there's anything in the book about parallelograms, or do we have to think a little harder than that? So apparently I have to think a little harder than that. So yeah, okay, so if we know A and B and we know theta, this is this triangle. So what we can do is we can then, the other thing too is these triangles are similar to each other, these two here. So knowing theta and A and B, we can figure out what this angle is. So we'll call that alpha. And then if we know alpha, what can we do with that? So I'm going to pause again to think about this. Okay, we'll do a little thinking there, but one thing you'll notice is if this is 45, then this is 45. And so phi, 2 phi is going to be equal to 360 minus 2 theta, because the sum of the interior angles of a parallelogram are equal to 360. Because you've really got 2 triangles. So for our case, you got 360 minus 2 theta, which is 45. So that's 360 minus 90, which is 270. 270 divided by 2 is 135. So we can kind of do all of these. 2 times this plus 2 times that should equal 360. So the same thing here. If you multiply this by 2, you get 240. 360 minus 240 is 120. 120 divided by 2 is 60. So that's that one. Here we can't. So for those two, we can do the angles. Now, so now what we have is we have this triangle AB with a diagonal with a diagonal D, and the angle theta is the angle opposite the diagonal. So we can use that triangle to figure out what D is. So what we'd have is, we're trying to figure out D, so we can say D squared is equal to A squared plus B squared minus 2AB times the cosine of D, but that's theta. So angle D would be associated with theta. So we can just now plug the stuff in and do the calculation. So A, looking up at the chart here, A is 5, B is 8, theta is equal to 45 degrees. So we get D squared is equal to So it's 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 45. And I get 58.7. So take the square root of that, and you'll get 7.66. Okay, so that's D is 7.66. And you can do the same thing with phi being 135 degrees. So this, so what we're doing is now doing this triangle. So we still have A and B, but we have phi being 135 degrees. And that, so the way we would do this is a side C. So you'd have C squared is equal to A squared plus B squared minus 2AB cosine of phi. So C squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 135 degrees. So C squared, okay, so we get 5 squared plus 8 squared minus 2 times 5 times 2 times 5 times 8 times the cosine of 135 degrees. And that is 145.6. Take the square root of that, and you get 12.1. So that's 12.1. And again, from a order of magnitude standpoint, you know, this is the larger angle, so you'd expect this distance to be larger. This side corresponds to this angle. This side corresponds to that angle. Okay, so the next one is exactly the same kind of calculation. So we can kind of just so D squared is equal to A squared plus B squared minus 2AB cosine of theta. So D squared is equal to 25 squared plus 35 squared minus 2 times 25 times 35 times the cosine of 60 degrees. So we get 25 squared plus 35 squared minus 2 times 25 times 35 times the cosine of 60. And I get 975. Take the square root of that. You get 31.22. 31.22. Okay. Now, you get C squared is equal to A squared plus B squared minus 2AC times the cosine of phi, which is 120 degrees. So we get 25 squared plus 35 squared minus 2 times 25 times 35 times the cosine of 120 degrees. And because this angle's bigger, this number should be bigger. So 25 squared plus 35 squared minus 2 times 25 times 35 times the cosine of 120. Ooh, that's a big number. Must have done something wrong. Yep. Made two mistakes. 25 squared plus 35 squared minus 2 times 25 times 35 times cosine of 120. You get 2,725. Take the square root of that, and you get 52.2. So this is 52.2, which is greater. So that all makes sense. Okay, now to the next bunch. They're kind of all the same. terms of that we're given 2 out of the 3 sides. So what you can do is, for example, here we know A, B, and we know C, so we can find phi from this triangle here. Once we have phi, we can calculate theta. Once we have theta, we can calculate d. That's the procedure we're going through here. So what I'm going to do is I want to erase some of this stuff here so I can have some room to do the calculation. Okay, so here we go. So what I said first was we're going to find phi. So we can say the cosine of phi, this is using the alternative form of the law of cosines. So it says the cosine of phi is going to be equal to a squared plus b squared minus c squared over 2ab. Because side C goes with angle phi. So we get the cosine of phi is a squared, which is 10, plus b squared, which is 14, minus c squared, which is 20, divided by 2 times 10 times 14. So 10 squared plus 14 squared minus 20 squared is negative 104 divided by 2, 10, and 14. And so we get negative 0.3714. And we can take the inverse cosine of that. And we get 111.8 degrees. So that's phi. So let's go ahead and put that in there. So that's this one. Phi is 111.8 degrees. So to find theta, we take 360 minus 2 times phi, and we divide by 2. Because 2 times phi plus 2 times theta equals 360. This twice plus this twice has to add up to 360. So we got 360 minus 2 times 111.8 divided by the whole thing divided by 2. So we get theta is 360 minus 2 times 111.8 divided by 2, and I get 68.2 degrees. 68.2 degrees. And then you can kind of see it's like the previous problems because you have 10, 14, 20, 25, 35, 52. You see here we have 120, here we have 112, here we have 60, 68. So this next one should be, this next length should be kind of equivalent, kind of close to that. So now what we do is, now that we have theta, we can use the law of cosines again. So the law here is with theta is a squared, b squared, and d. So we're trying to find d. So d squared is equal to a squared plus b squared minus 2ab times the cosine of theta. So a is 10, b is 14, and then we have 2 times 10 times 14 times the cosine of 68.2 degrees. So we get d squared is 10 squared plus 14 squared minus 2 times 10 times 14. Keep pushing the wrong button here. Times 10 times 14 times the cosine of 68.2 degrees. So that's 190.0. So d is the square root of that. and I get 13.9. So write that up there, 13.9. And you can see these two entries are pretty close to each other. So they all look like a reasonable situation. Okay, so the next one is very similar, except we're going to solve, because we have D, we can solve, D is this one, so we're going to solve for theta first. Then we can calculate phi. Once we have phi, we can calculate C. So these two are similar. These, and then the last two are going to be similar as well. So again, let's delete some numbers. Let's delete some stuff. Make some room. Okay. So again, we have A and we have B and we have D. So we're going to calculate theta. So we're going to say the cosine of theta is equal to A squared plus B squared minus D squared divided by 2AB. So A in this case is 40. So we have 40 squared plus 60 squared minus 80 squared divided by 2 times 40 times 60. So the cosine of theta so we end up with negative 0.25. So again, taking the inverse cosine of negative 0.25, we get 104.5 degrees. So that's theta, 104.5 degrees. So phi is 360 minus 2 theta over 2, just like we had the similar kind of equation for phi. So you get 360 times 2 times 104.5 divided by the whole thing divided by 2. 360 minus 2 times 104.5 divided by 2, you get 75.5 degrees. 75.5 degrees. Okay. Now, what we have now is we have phi, A, and B. So that means we can calculate C. So C squared is equal to A squared plus B squared minus 2AB times the cosine of phi. C squared, so A squared is 40 squared plus B, which is 60 squared minus 2 times 40 times 60 times the cosine of 75.5 degrees. Okay, so 40 squared plus 60 squared minus 2 times 40 times 60 times the cosine of 75.5. You get 3998. Take the square root. You get 62.2. 62.2. So you'll notice that I deleted the last two problems out of that table. They were much more complicated than I really wanted you to do once I got working through them. So first I was like, oh, I'm not sure how to do these, but I figured out an approach, which we could have done, but it would have taken at least 2 or 3 times as long as the ones we've just done, so I didn't want to do that. Okay, so the next formula is this, our next 3 problems are just using this Heron's area formula. And what it says is the area of a triangle is equal to the square root of S times S minus A times S minus B times S minus C, where S is the average of the lengths of the three sides. So it's A plus B plus C divided by 3. And they just, instead of plugging this in, if you put A plus B plus 3 divided by A plus B plus C divided by 3 in there, it would be going to look too complicated. So they just kind of make it more manageable. So in these cases, we're just given everything. We just have to plug it in the formula. So that's just a piece of cake. So let's do first. So first we'll calculate S. So it's 5 plus 7 plus 10 divided by 3. And I need to get my calculator. So that's 5 plus 7 plus 10, 22 divided by 3. So we get 7.33. And the area is the square root of 7.33 times 7.33 minus A, which is 5. A's this one, B, C. And something doesn't quite seem right. Oh, that's because this is divided by 2, not 3. The reason I knew something was wrong is because I was going to get a negative number in the square root. So I looked at the formula again. So this is 22 divided by 2, which is 11. So we get 11 times 11 minus 5, 11 minus 7, 11 minus 10. You can see, I guess when you divide by 2, you're always going to get this result always being larger than all of the 3 individual ones. So that's the square root 11 times 6 times 4 times 1. 11 times 6 times 4 is 264. Square root of 264. It's 16.2. So that's the area. Do the same thing for 9. Calculate S. That's 2.5 plus 10.2 plus 9 divided by 2. And that should be greater than any of the individual ones, which it is. And then the area is 10.85. And you have 10.85 minus 2. 10.85 minus 10.2. And 10.85 minus 9. And so let's just stick that in the calculator. And I get 10.75. And I'm just going to pause to make sure these are correct before I continue on. Okay, so you can see the answers changed. The issue was here, I had 2 instead of 2.5. So I don't know why I wrote down 2. First I redid the calculation, got this number wrong. But then I realized the number was even worse. So anyway, you can look at that and pause it. And then finally, number 10. So S is the average of those well, not the average, but it's that divided by 2. Sum of those divided by 2. So we get 3.125, and the area is equal to the square root of 3.125 times 3.125 minus 3.05, 3.125 minus 0.75, and 3.125 minus 2.54. So we'll do that in your calculator. So make sure you do it so you know the procedure. So if you have this on a test, you've had experience in putting in your calculator correctly. And so I get 0.613. So we'll pause again. Okay, so that one's correct. Okay, now we got a couple of word problems. How many do we have here? So we have 4 word problems. And some of these have pictures, some of them don't. This one doesn't have a picture in the book, so we're going to have to make the picture. A plane flies 810 miles from Niagara to Cuyahoga with a bearing of 75 degrees. Then it flies 648 miles from Cuyahoga to Rosemont with a bearing of 32 degrees. Draw a figure that visually represents the problem and find the straight line distance bearing from Niagara to Rosemont. So if you remember how we do these compass settings here. So this is north, south, east, and west, and these are all relative to north, and you go clockwise. So it says bearing is 75 degrees. So we're going to start here at Niagara, and 72 degrees is going like that. So this is the starting point. This is Niagara. Okay, so this angle is 75 degrees. Okay, then we go from Cuyahoga to Rosemont with a bearing of 32 degrees. So 32 would be a little bit closer to north. So let's draw this thing down. So we go kind of like that. So again, if you draw a vertical line like that, this angle is 32 degrees, and as a consequence, to go back from Cuyahoga to Niagara, you'd have something like that. So we'll call this Cuyahoga. The interesting thing is I know where Cuyahoga is in Ohio, so this doesn't, from a map perspective, it doesn't make sense to me right now, but you know, I don't know if they've just made these names up. Anyway, maybe this is not Niagara Falls, it's just Niagara. Okay, so now we got to figure out how we represent these angles relative to this triangle, this particular triangle, and this is 800 and This is 810 miles. This is 648 miles. So to use the law of cosines, we'd actually have to know this angle. So the question is this angle here somehow related to these two particular angles? So let's think about that. So if I were to just draw this line out, so from vertical to here, this angle is 75 degrees. And this angle is 32 degrees. So what does that tell us about anything? Well, one thing is, if we drew a horizontal line here, and this is a vertical line, this is 75 degrees. Okay, I'm pausing for a second here. Okay, so if this is 75 and this is 32, then this angle here is the difference between the two. So that's 75 minus 32. So this angle is 43 degrees. And as a consequence, this angle, because this is a straight line, this angle here has to be 180 minus 43, which is 137 degrees. So let's, now that we've kind of put all this together, we need to create a triangle that we only label what we need to know. So let's use red here. So we have this part, we have this part, and we have this part. And what we said was this was 810, this is 648, this angle here is 137 degrees. So if we call this angle A, this side A, this side B, this side C, and we want to find A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. So we know everything on the right-hand side. So we get A squared is equal to 648 squared plus 810 squared minus 2 times 648 times 810 times the cosine of 137 degrees. So plug those in. 648 squared plus 810 squared minus 2 times 648 times 810 times the cosine, make sure I'm in the right mode here, yep, cosine of 137. So you get 1459874, and if you take the square root of that, you get 1208 miles. Okay, so let's check the answer. Okay, I made a calculator error. So this should be 1,843,749. Take the square root, you get 1357. What I did was I got a multiplication. I did subtraction instead of multiplication. Okay, so that's correct. Now, to find the bearing of this part right here, so this is the bearing that I'm looking for. I know the angle between north and here, that's 75 degrees. So if I find this interior angle, I can take this angle and subtract that angle. That'll give me the bearing for this line between Rosemont and Niagara. So I can use either the law of cosines or the law of sines in this case, because now I have all three lengths, so I can figure out the cosine of the angle. So since we're dealing with the law of cosines, let's just use that. And so this would be the cosine of B, which is this angle, is going to be equal to a squared plus c squared minus b squared over 2 times a times c. So that's the alternative form. You're always subtracting the letter that corresponds to the angle. And A, we just figured out, was 1,357 miles. So we got 1,357 squared plus 810 squared minus 648 squared divided by 2 times 1,357 times 810. And that's going to be the cosine of this angle. So let's do that. 1,350 squared plus 810 squared minus 648 squared, and divide that by 2 and 1,357 and 810, and I get the cosine of B is 0.945, or B, using the inverse cosine, is 19.1 degrees. So the bearing that I'm looking for in the answer is going to be equal to 75 minus 19.1, which is 55.9 degrees. And that sounds familiar, but I'm going to check the book anyway. They say 56, which is the same as 55.9. So what I've done is I've found this angle right here. This is angle B. This is angle C. This is angle A. So what it is, I took 75, this angle, between the north and going from this place to this place, and subtracted the interior angle to this triangle to get the bearing. Okay, next one. A triangular parcel of ground has sides length 725, 650, and 575. Find the measure of the largest angle. Well, the largest angle is going to correspond to the largest distance. So we can draw a sketch, just a rough sketch here. So let's I'm going to make it something like that. It's really probably not a right angle, but I just wanted to make this the longest one. So this is 725. This would be 650. This would be 575. The largest angle would correspond to that. So we could call this angle A, we call this side A, call this B, call this C. We don't need to know what these other two angles are. So because we're trying to find the angle, we'll use the alternative form. We'll say the cosine of A is, well, this is A, so we use the other two letters, B and C, and subtract A. Of course, they're squared. And then you divide by 2 times these ones, they're positive, 2BC. So you get the cosine of angle A is equal to B squared plus C squared minus A squared, the longest side, 2 times 650 times 575, cosine of A. Plug those in the calculator. 650 plus squared plus 575 squared minus 725. 725 squared. That's the numerator. And you can divide by these three things. You can do it individually because they're just multiplied in the denominator. So I get 0.304. And so A is the inverse cosine of 0.304. Inverse cosine of that, and I get 72.3 degrees. So that's what this is. And this, we know it corresponds to the largest angle because that's the longest side. Okay, so that's right. Got two more. The baseball player in center field is playing approximately 330 feet from the television camera that is behind the home plate. A batter hits a fly ball that goes to the wall 420 feet from the camera. See the figure. The camera turns 8 degrees to follow the play. Approximately how far does the center fielder have to run to make the catch? Okay, so I'm going to draw the picture for you. You've got home plate here, and then you got the 3 bases like that. Out here you got a fence. This guy's in center field here. The ball is hit to the wall just a little bit to the right. So this is from the home plate, which is where the camera is. And then he has to run like this, and that's the situation. So it says the baseball player in the center field is approximately 30 feet. So this side of the triangle is 330. So that's this distance from home plate to the player. The distance from here to here is 420 feet. And this is the camera turns approximately 8 degrees, so that's this particular angle, 8 degrees. And what we want to do is figure out what is this distance. So we have everything. We have the 2 sides adjacent to the angle. So again, let's draw a triangle by itself. So we've got a triangle that looks like this, goes out there. Goes a little bit in that direction, like that. Let's call this angle A. We'll call this side A. This is side B. So opposite side B is angle B. Here's C. This is angle C inside. These are the internal angles. So what we can do is we're solving for A, the distance A. So A squared is equal to B squared plus C squared minus 2AC, or BC, to BC times the cosine of the angle A. So in our case, B is equal to 330. C is equal to 420, and this angle here is 8 degrees. So we get A squared is equal to B squared plus C squared minus 2BC times the cosine of 8 degrees. So we get A squared. Plug that into your calculator. 330 squared plus 420 squared minus 2 times 330 times 420 times the cosine of 8 degrees. And that's 10,797. Take the square root of that. You get 104 feet. And that's the right answer. Okay, and then finally, we've got 2 aircraft that are flying. To determine the distance between 2 aircraft, a tracking station continuously determines the distance to each aircraft and the angle between them. See the figure. Determine the distance A between the planes when the angle A is 42 degrees. B is 35 miles, C is 20 miles, so we've got B equals 35. We've got C equals 20. We've got angle A is equal to 42 degrees. So it's just like the previous problem. What we want to do is figure out what size side A is. So A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So we just plug those in. This triangle is pretty self-explanatory. It's not a lot of excess, so we don't really have to spend we don't need to recopy it, I don't think. So we get 35 squared plus 20 squared minus 2 times 35 times 20 times the cosine of 42 degrees. So we plug that in our calculator. 35 squared plus 20 squared minus 2 times 20, 35 times 20 times the cosine of 42 degrees. So that's 584. And if you take the square root of that, you get 24.2 miles. Okay, so that's right. So we're done.